And in today's lesson, we're going to talk about solving single-step equations. What do I mean by single-step equations? Well, and what do I mean by solve? Well, this would be your instructions. Solve. And then you would see something like x plus 3 equals 5. Now, when you're asked to solve, they're asking you to find out what number do you have to put in for x that will give you a true statement. So some of you are going, oh, I guess it's going to be 2 because 2 plus 3 is 5. That's okay, but we want to develop a methodology by which you don't do this by guessing. So yes, I'm going to require you to show work. And okay, got it. Let me see if this works. I'm learning new tools here, so you'll just bear with me. So I think that should give me back my pen, but it's not. And no, I'm not getting back my pen, so I'm going to go back and grab my pen. There we go. All right, it's still not giving me back my pen. There we are. X plus 3 is 5 was our original problem. And we're supposed to solve. It means find a value of x that makes this true. So it's helpful sometimes to write out the x plus 3 is 5. Okay, that's kind of going backwards. You might not write that out as you're doing this, but let's think about it. 3 is added to x is a piece you might want to either think about in your head or write down. So you want to undo adding 3. Now some of you, this is overkill, so you can fast forward the video, but so how do I undo adding 3? Well, I don't want to add anything to x. I want x by itself. So if I have a positive 3 added to x, if I add the opposite of that, which is a negative 3, I'll get just x. But in order to keep this equal sign true, I would also have to add a negative 3 to that side. Remember, adding a negative is the same as subtracting the positive. So here, I have a positive 3 and a negative minus 3, so that gives me a 0. And that's what I wanted. I wanted x plus nothing. 5 minus 3 gives me a 2. We don't write the 0 so x equals 2 as our answer. So your work for this problem would look like this. And this is what I would want to see. I would want to see you subtracted 3 because your goal is to get x alone. So you look at the side of the equation that has the variable, it has the letter, in this case it's an x, and you decide what is done to that x. What's done to it is 3 was added. So in order to make it 0 added, I have to add a negative 3, or I have to, instead of adding 3, subtract 3. But the law of equality says I have to do that to both sides of the equation to keep this equal sign valid. So when I do that, and you can think of this as negative 3 equals negative 3, you're like adding two equations almost. X equals 2. So that one wasn't so bad. I don't think anybody would argue about me making you do a bunch of those on a test. Let's try another one. Let me look for my clear the canvas. So again, your instructions are to solve. This time I'm going to say 20 equals x minus 5. Now solve means you want to get the variable, the x in this case, again alone. It could be an n, it could be a p, it could be whatever your letter is that's your variable. Students often get confused. They always want to work with the left side. No, you have to decide which side of the equation to work with first. We're going to work with the right side because that's where the letter is. And I want to get x all by itself. But I have x, when I subtract 5 from x, I know I have 20. So the opposite of subtracting 5 would be to add 5. And some of you may see it better if I do this. Just give me 1 second here. Some of you might see this better if I write it like this. If I add 5, if I subtract 5 and then I add 5, I'm just left with x because it'd be x plus 0. But if I added 5 there, I have to add 5 here. So there's my 25. That's not usually the way you write it out, but that's what you're doing. You're adding 5 to both sides of the equation. So I show that by writing two addition problems, essentially vertically. I added 5, and the reason I added 5 was I looked at the side with the x. I had x minus 5, so I have to add 5 to make it 0. And I get 25 equals x. So you have to look at which side has the variable. Let's try another one. Now let me actually erase the I'm going to erase the whole board here. All right, let's try another one. 2 plus x equals 15. You want to get x by itself. Your instructions are solve. Those will be instructions here all the time. Hopefully I haven't written that off the screen. So it's harder to see. Okay, so the x is on the left side. So I'm going to work with this side of the equation because that's the side that has the letter in it. I want to get the letter by itself. Okay. So this is addition. Remember, addition can be, the order can be rewritten. It's commutative. So this equation is the same as asking you to do x plus 2. So it might be easier for you to see it if you write it that way. But what happens is you have the 2 plus an x equals 15, and you want 0 plus x equals 15. So if you subtract 2 from the 2, that'll give you a 0 plus x, but you also have to subtract 2 on the other side. So you're using the side with the letter to decide what you're going to do to both sides of the equation. And when you have 0 plus something, you don't write it. You just get x equals 13. Or you could turn this around if that makes it easier for you. Now you see you subtract 2 from both sides, and you get x equals 13. All right, there's another way this could become complicated. Oh, I keep doing that. I need to do this. Clear the canvas. Another way this could happen is I could have 5 equals negative 3 plus x. Wait a minute, negative 3 plus x. Well, first of all, I'm going to work with the right side to decide what to do because that's the side with the letter. I want to make the negative 3 into a 0, so I add its opposite. If I do a negative 3 plus 3, I'll get 0. So I do that on that side, and I also do it on this side, and I get 8 equals x. Now, how do I check my work in these? Well, I go back to the original problem, and I replace the variable, the letter, with the number I found. And I'm checking to see if this is correct. Okay, so this is checking. Does 5 equal negative 3 plus 8? Yes, it does, so my work is correct. That's how you can check your work on these. All right, so that's solving single-step equations with addition. And now I want to look at what happens if we don't have addition, what happens if we have subtraction. And then in another video, we'll look at multiplication and division. So what if I start with x minus 17 equals 12? I'm going to work on the left side because that's where the letter is. I have 17 subtracted from x, x plus 17. If I subtract 17 and then I add 17, it's the same as having done nothing to the x. I get x plus 0, and then 12 plus 17 is 29. So if it's subtraction, and remember, x minus 17 is the same as saying x plus a negative 17. So you want to remove the negative 17 from this side, so you add its opposite. You add a positive 17. That's the same exact, this would be the same problem as this is. All right, so if you have questions, I'd like you to email them to me, but I'd also like you to watch the next video where I talk about what you do when you have multiplication or division. Stop.